In the morning, as the child is having his breakfast, he is given a glass of milk and his father is given a cup of tea. The child notices a glass of milk and a cup of tea on the breakfast table. Let us assume the volume of milk in a glass as X and volume of tea in a cup as Y. The child observes the volume of milk in a glass is 3 times the volume of tea in the cup. Hence, volume of milk in a glass is equal to 3 times volume of tea in the cup, that is, X equal to 3Y. Now, the kid pours milk and tea in a measuring cylinder. The volume of both the glasses of milk and cup of tea turn out to be 400 ml. Hence, we can say that sum of the volume of milk in a glass and the volume of tea in the cup is equal to 400 ml, or X plus Y is equal to 400 ml. So, the two equations formed are X equal to 3Y and X plus Y equals to 400. These equations form a pair of linear equations in two variables. Therefore, the given set of equations is X plus Y equal to 400, X minus 3Y equals to 0. This pair of equations can be represented in the form of determinants as shown here. This means a system of linear equations like A1x plus B1y equals to C1, A2x plus B2y equals to C2. This can be represented in the matrix form as shown here. Now, this system of equations has unique solution or not is determined by the number A1b2 minus A2b1. Recall that the system of equations have a unique solution if A1 divided by A2 is not equal to B1 divided by B2, or A1b2 minus A2 into B1 is not equal to 0. The number A1b2 minus A2b1, which determines uniqueness of solution, is associated with the matrix A, A1b1, A2b2. And this is called as the determinant of A or determinant A. The determinant of a matrix A is denoted by det of A or det A or A within vertical bars or delta A. Here, for a given matrix A, the corresponding determinant is expressed as shown here. Similarly, for an order 3 matrix, the determinant is as shown here. In this chapter, we shall study the determinants up to order 3 only with real entries. To every square matrix A, we can associate a number real or complex called the determinant of matrix A. In other words, determinant is a scalar value assigned to a square matrix. So, determinant can be thought of as a function which associates a square matrix to a unique number, real or complex. Determinant of a matrix A is denoted by det A or A written within vertical bars or delta A. Let's check the determinant of order 1. For matrix of order 1 containing the element A, the corresponding determinant will be the same element A as shown here. The number A represents the value of the determinant associated with the matrix. For example, in case of matrices shown here, the corresponding determinant will be as shown here. Next is determinant of order 2. For the matrix of order 2, the corresponding determinant will be written with vertical bars instead of the square brackets as shown here. The number obtained by subtracting the product of its diagonals gives the value of the determinant. For example, the given determinant A as shown here. It can be evaluated by multiplying its diagonal elements and subtracting them as shown here.